Dirichlet's jar principle. So it's also known as the pigeonhole principle, Dirichlet's box principle, or Dirichlet's box principle. So if n items are put into m containers, and and n is greater than n, so the number of items is greater. The number of items being put into the containers is greater than the number of containers, then at least one container must contain more than one item. So for example, if n plus 1 objects are being placed in n boxes, then one of those boxes must contain more than one object. So prove that for 13 people, there must be 2 of them with birthdays in the same month. So for each year, there are 12 months, and we can take each month as a pigeonhole. So each person will be a pigeon. So for pigeons from P1 to P12, each pigeon is assigned to a pigeonhole. Pigeon P13 needs to be assigned from one of the holes from 1 to 12, so H1 to H12. However, for each of the pigeonholes, there is a pigeon assigned already inside. So the 13th pigeon must share a pigeonhole with one of the other 12 pigeons. Correspondingly, there must be 2 people that have the same birthday in 1 month. Same principle. So a more formal definition. For natural numbers k and m, n equals km plus 1. Objects are distributed among m sets. Then at least one of the sets will contain at least k plus 1 objects. So let's assume there are m pigeonholes, and if there are km plus 1 pigeons, then at least one of the holes will contain at least k plus 1 pigeons. For example, 5 pigeons, 2 pigeonholes. So n equals 5, k equals 2, and m equals 2. So 5 times 2 plus 1, at least one pigeon hole will hold more than, will hold, at least one of the pigeonholes will hold 2 plus 1 pigeons, or 3 pigeons. Students in a university lecture have black, brown, red, green or blue, and white hair. There are 101 students in the lecture. Show there are at least 21 students who have the same hair color. So the pigeonholes here are the hair colors. So there are 5 of these because there are 5 choices. Keep in mind, green or blue is one choice. The pigeons are the 101 students in the lecture. And in this question, then, n equals 5, and mn plus 1 equals 101. So m plus 1 equals 21. By the more general pigeonhole principle, there must be at least 21 students in the lecture who have the same hair color. So prove in a group of 6 people at a party that there are at least 3 people who mutually know each other, or there are at least 3 people who are mutual strangers. Proof. So you randomly pick one person from the group of 6 people and you take 2 pigeonholes. One of them for people who knew each other, and one of them for the strangers. So you assign the rest of the 5 people into the 2 pigeonholes, and 5 equals 2 times 2 plus 1. So according to the pigeonhole principle, at least one hole contains 2 plus 1 equals 3 people, that people like that know each other or not. So there there are at least 3 people who mutually know each other or who don't know each other. So there are like a few types of pigeonhole problems. Some of them are quite easy, some of them are hard. But the key to them all is to construct the pigeonholes